What is up, bros? Care to Math. We are here today talking about some special cases of factoring. The first we're going to talk about is difference of squares. I hope you like my meme here. I believe that is a puffin. So the first one we got is difference of squares. Here's the little formula that you can use that we're going to use. Maybe you want to memorize, whatever you want to do. A squared minus b squared equals a minus b a plus b. So basically what this is all the ones that we're going to factor. There's a certain formula you use. There's certain numbers that are used. It makes your life a lot easier. So basically when you can get to the point where you can start to look at it and you'll be like, bang, I know that's a difference of squares. I can just go ahead and set this up. So let's talk about it for a little bit. So first thing we want to do is we want to figure out, well, what is my a squared? What's my b squared? Well, if I look, a squared is just the thing that's out in front. So my a squared is going to be m squared. And my b squared is whatever is last. So that's just 9. And then to figure out, well, if a squared is m squared and b squared is 9, how do we figure out what a and b are? Well, here's the deal. This is why it's called difference of squares. If we take a look over here at this list right here, these are perfect squares, right? So you know, square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. How did we get 1? Well, it's 1 times 1. How did we get 4? Well, it's 2 times 2. 9 is 3 times 3, right? So if you look, every single one of these numbers comes from two numbers multiplied by themselves. It gives you that number, right? So I want you to think about the same thing when you see something like, well, m squared. Because all that happens is this. If I want to figure out what a and b are, I would ask you this. I would ask you, let's start with b squared. How do I get rid of the square right there? You would tell me, all right, well, you square root both sides. What is the square root of 9? Well, let's look over here. The square root of 9 is just 3, right? Well, if you look, this b squared became b. Why did that happen? Here's why. Because this is a square root, which means that this little thing in here inside this little triangle, that's called the index. The index of a square root is 2 squared, right? Square something, it's a 2. So if you look, that index, this is a 2, and this is a 2. So basically what happens is, what's 2 divided by 2? 2 divided by 2 is just 1. So this becomes b to the first, and it's no longer underneath a radical. So when you take the square root of both sides, what it does is it gets rid of that. So whatever you have, if you take the square root of x squared, it's just x. If you take the square root of b squared, it's just b. If you take the square root of q squared, it's just q. Square root of m squared, it's just m. Are we seeing what's going on here, right? So this is just that pattern you can start to notice. So if we take, again, now the square root of both sides, what happens is the square root of a squared is just a. The square root of m squared is just m. So all I'm going to do, now that I have my a and my b, I just got to plug my a and my b into this equation up top here. So I get a is m, b is 3, but I need a minus and I need a plus. The m doesn't change. And if you look at my original, right, I had m squared minus 9. Negative 9. How do we get that? 3 times negative 3, which I have, right? 3 times negative 3. What is 3 plus negative 3? It's 0. So my middle term, I don't have one. It's 0. So what multiplies to negative 9 adds to 0. That's another way to think about it. But what I want you to start to realize is this. all the ones, and if we look at example 2, all the ones that we're going to work with, all the things that we're going to factor, they all have one of these numbers in them. So what you can start to do is just take a look. If I see 2 terms and I see a minus sign, it means it's a difference of squares, so I can use this formula right here. So let's take a look. 25, is it on this list right here? It sure is. Square root of 25 is just 5. So if I want to take a look at what a squared is, well, a squared is just 25 b squared. Sorry for the b there, it's a little confusing, but it's different from this b squared. Well, what's b squared? Remember, b squared just the number behind, so that's 1. So how do I get rid of the squared, or how do I just get a? I take the square root of both sides. A just becomes, what's the square root of 25? It's 5. What's the square root of b squared? It's just b. And then I take the square root of both sides here. I just get the square root of b squared. We already discovered over here is just b. And the square root of 1 is just 1. So now all I have to do is plug it into this bad Larry. A minus b, a plus b. So what's my a? My a is 5b. I have minus 1. And then I have 5b plus 1. And that's my answer. So, biggest thing that I want you to remember is this. You see 2 terms. Both terms are perfect squares, meaning they're on this list. Perfect square. They're on that list. And there's a minus sign in between the 2 terms. That's what we're dealing with here. So 2 terms, both terms are perfect squares. There's a minus sign in between the 2 squares, right? Or in between the 2 terms. Minus sign, 1 term, 2 term. Minus sign, 1 term, 2 term. Thanks for watching. Thanks for playing along. I had some fun. I hope you did too. Go Math.